everything you say may be picked up by the microphone, which would make it part of the class recording, and it will be posted on YouTube. So if you don't want your mom to hear, you know, you being stupid, don't be stupid.
All right, I'll try.
All right. Starting off, let's go here. Okay. Last week, the fact that it's 14, that means it's recording. So,
Wow.
so there's a little red dot when it goes red. That means it's recording. So, all right. Try to focus. All right, try. Do your best.
It's really hard.
I know. All right. So last week, we started on measurement, and we talked about that every measurement has two parts. They are
Certain, uncertain.
certain and uncertain. Kelly, where did the certain digits come from?
On the line.
On the line on
A measurement, a ruler.
the ruler that we're using, or the measurement tool that we're using. And then the uncertain digit is
Estimated guess.
an estimated guess of where it is
In between.
in between the two lines.
Yeah.
Okay? Both of those parts make up your measurement. They are both important parts of the measurement. Even though one is certain and some are uncertain, they are both important parts of the measurement. Therefore, together, they are both considered the significant digits that are in your measurement. So, significant digits is a measure of the certainty of your measurement. Remember, we don't know any values for sure. There are acceptable measurements and unacceptable measurements. There are some measurements that we might know a little bit more certain, feel a little bit more certain with than other measurements, depending on the ruler that we use, but we never know anything for sure. All we can talk about is how certain we are. The greater number of significant digits, the more certain you are of your measurement. Because the number of significant digits equals the number of digits that are certain, which come from, where do our certain digits come from? The ruler, right? Plus 1, which is our uncertain digit.
Yeah.
So the number of significant digits is those two added together. I'm not creating easy. I tried to, but I couldn't. There was something wrong with the program, and I really didn't want to record you guys because of this. But
Is every class like that?
you guys are special.
Of course we're special.
All right, so
And you have white.
you do not have this picture, but in your head, not yell, in your head, if you had to record a measurement of the volume of the liquid that's in that graduated cylinder, what might you write down? In your head. Okay, so what would be an acceptable recording of the volume of that measurement? Aaron, go ahead.
6.24.
6.24, Aaron says. Is that acceptable?
Yeah.
Yes. Okay.
6.23.
6.23, another acceptable answer.
6.22.
6.22, another acceptable answer. Anybody think that it looks to be about a quarter of the way between 6.2 and 6.3? But can we go 6.225?
No.
Right? Too many certain digits. Okay. All right, Aaron. We got to the answer of you got to your answer of 6.24 because how?
Because it's past the 6.2 line and before the 6.3 line.
So that gives you your
Uncertainty.
So that gives you the that gives you what part of your measurement? The certain digits, right? And how many certain digits are there in this measurement? 2. Plus how many uncertain digits?
1.
For a total number of 3. So this measurement has 3 significant digits. Even though some are certain and some are uncertain, they're all important to our measurement. So 3 significant digits. What we find out is, looking at a measurement, you should be able to tell which ones are significant and which ones aren't. Which ones are certain, which ones aren't, even if you don't have the ruler. But what we find is that there are patterns that develop, right? There are rules that come out of all measurements. So instead of each time you guys figuring out what's certain and what's uncertain just by looking at it, if we follow the rules, you'll get to that answer as well. So here are the rules. First, any non-zero digit is going to be significant. Always, always, always. Because non-zero digits come from the ruler. So any non-zero digit is going to be a significant digit. All non-zeros are significant. Why is that confusing?
Why do I break it down into like so many parts?
Because
That's
that's,
just how it goes.
Why
that's
can't
how
they
it
do like
goes.
this number on the
Well, I
rule?
mean, you could figure it out just by looking at it each time.
Yeah,
But, you know.
yeah, why can't they do that?
All right, you can do that if you want. All right. He's just trying to get attention. All right. The next rule deals with sandwich zeros, or zeros between two non-zeros. Sandwich zeros are always significant. So if you read the ruler and it's 707, that's 3 significant digits because the 0 is significant there because it's sandwiched.
I remember this from last year.
Good. It doesn't matter how many zeros are sandwiched. All of them are significant. So 707 is 3. 7007 is 4. Okay? Doesn't matter how many zeros are there. They're all significant. The hard part comes with zeros at the beginning and zeros at the end. And the biggest key being if there is a decimal point. So, if your quantity has a decimal point, it doesn't matter where, it just has to show up. First, zeros at the beginning are never significant. Zeros at the beginning are never significant, regardless of how many there are, whether they come before the decimal or after the decimal. If they're at the beginning of the numbers, they are never significant. Zeros at the end. Zeros at the end are significant if there is a decimal point. If there is not a decimal point, they are not significant. Julie, go ahead.
So is that, are you talking about like a decimal point in the figure or a decimal point near the figure?
Anywhere in the measurements. So I'll give you some examples of how that works. Okay. Poppy, go ahead.
What if it's like a whole number, like down here it says 7,000? Those are still significant, right?
Let's talk about that. So,
If they weren't significant.
all right. That's okay. That's good.
It's because I'm sick.
All right. We're about, I don't know, 10 minutes in. All right. Does everybody have this down?
Yeah.
Okay. Let's practice. Let's talk about some examples.
Okay.
Okay. All right. First thing I'm going to do
Purple.
is
We didn't get purple.
okay. There's a ruler. All right. So let's start with this line. If we had to measure that line, what would be an acceptable measurement of that line?
68 point.
Okay, so 68.6. Kenny, how many certain digits in that number? 2. How many uncertain digits? So a total of
Three
3
significant.
significant digits. Okay, good there. Alright. Next line. Okay. Johnny, go ahead. Okay. So, we need the 0 there, right? Because how many certain digits does that have? 2. How many uncertains do we need? 1. It just so happens that our uncertain digit in this case is what? 0. For a total of significant digits. Rule D that you just wrote down. Zeros at the end are significant if there is a decimal point. There is a decimal point. Okay? Alright, next.
Ooh, that's a pretty color.
Okay? Steve, go ahead. 70.0 centimeters. Right? Steve, how many certain digits in that answer? 2. How many uncertain? 1. Total of 3 significant digits. Rule D that you just wrote down says zeros at the end are significant if there is a decimal point. Regardless of whether it comes before the decimal point or after the decimal point. Those 2 zeros are both at the end of the measurement. One comes before the decimal point, one comes after, but because they're all there and there is a decimal point, they're all significant. Okay? Good there. Okay. All right. Next ruler.
It's funny, white.
Okay, so here's our next ruler.
I see.
Okay?
Go on.
How would we measure that line? Okay, go ahead.
1,500.
We'll call that centimeters too, just in case. Okay? All right, so how many certain digits in that answer?
1.
1. What's the certain digit in that measurement?
The 1.
The 1, the 1,000, right? How many uncertain digits?
3.
1.
1.
How come?
Zeros.
How many
Oh yeah, but there's no decimal point.
Wait. How many uncertain digits does any measurement have?
1.
Only 1.
Ah.
So that means that this number here has how many significant digits?
2.
Only 2.
I got it.
Based on what we know for sure and what we don't. Rule D says zeros at the end are significant if there's a decimal point. Is there a decimal point in that number?
No.
So how many significant digits? Just 2. Okay? Alright. I'm going to draw you another ruler, then we're going to come back to this one.
Oh, why?
Alright, so here's 2,000. But this is like a close-up view. Alright, so this one, right, do we see the difference in the top ruler and the bottom ruler?
Yeah.
Okay.
What was my birthday?
Okay? Manny, go ahead. 2,000.0.
Oh, I get it.
Okay? Manny, how many certain digits in that number?
4.
4. How many uncertain digits?
1.
Total of?
5.
5. Rule D says zeros at the end are significant if
There's a decimal
there's a
point.
decimal point. Okay? So that's 5. All right. Are we ready?
Oh, yeah.
highlighted the same color?
It's like the same line.
It's like the same line.
Same thing.
It's not the same thing.
Okay, it's the same line, but is it the same measurement? Why? What's different?
The ruler.
Because on the bottom one, you're just going from one number to the next one up, and on this one, you're going from 1,000.
Okay, so more generally, Kenny, what changed? What's different?
The integers on the ruler.
Or the marks on the ruler, right? Yeah, so the marks on the ruler determine what for us? The number of?
Significant
Significant,
figures.
uncertain digits.
We got it
Process of
eventually.
elimination. Alright, the numbers on the ruler tell us the number of certain digits.
Yeah.
Okay? So, going back to the red line. The red line had one certain digit, one uncertain digit, for a total of 2. The top blue line. Are we using a different ruler?
No.
We're using a different ruler from the bottom blue line to the top blue line. Are we using a different ruler from the red line to the top blue line?
No.
No. Meaning that any measurement that we take with this ruler
I got it.
should have the same what? Significant digits.
Had that.
Okay?
That was in the math.
How would we write the measurement of this blue line up at the top?
2,000 centimeters.
Are we sure?
Good job. 0 centimeters for the other one.
I wrote 10 meters.
Yeah.
Regardless. Okay. Problem. As it's written, that measurement only has how many significant digits? One. But how many did the red line have? 2. If we haven't changed the ruler, how many significant digits are we supposed to have? 2. We can't write it this way.
No.
Right? Not according to the top ruler. Right? The top ruler doesn't have that much certainty. It doesn't have that many lines. Okay? So, that leads us to our 5th rule. That's kind of a catch-all. Gets us out of bad situations like this. That 5th rule being scientific notation. There we go. All right. Scientific notation can be used to show which numbers are significant. Anything written in the coefficient portion of a scientific notation is significant. Okay?
I know why.
So,
I got it.
that being said, let's go here. And I think it's going to mess me up. Nope, it's good. Okay, so this 2,000 right here, if we had to write it in scientific notation, if we have to write it in scientific notation, how would we turn that number into scientific notation? Rito? Okay, that's that number in scientific notation. Okay? But I just showed you that we can use scientific notation to show significant zeros. So here, right? If I make it 2.0 times 10 to the second, that's only how much?
2,000
2.0 times 10 to the second is scientific notation, but it's only what number? It's only 200.
Oh.
But 2.0 times 10 to the third, right? If we move this over 3 places, what do we end up with?
2,000.
2,000. But by showing this in the coefficient,
We're saying
it
that
doesn't
we
change the value, it just changes what's significant in the value. Okay? So, long story short, anything that you write in scientific notation is significant. Okay? Good there. Those are your 5 rules. Okay, Libby, go ahead.
You have to write it 2.0, you just have to write it 2.
If you don't write 2.0, anything that we write in scientific notation is significant. So if you just write it as 2, how many significant digits does that number have? Just 1. But we talked about this idea that the red and the blue both have to have 2 significant digits. So you have to include that 0 to show that the one of the 3 zeros is significant, but the other 2 aren't. Okay? Alex, go ahead.
So like if 2000 had 3 significant digits, can you do it 2.00 times 130?
Yep. That's showing you that the first 2 zeros are significant, but the last one isn't.
That's so cool.
Okay? We could do that if we change this ruler to look like this. Okay?
We did that on 2001.
That's 2,100. Okay?
Oh.
Because here, if we do this, right, Alex, if I write 1900, then now the 19 becomes the certain part, and you have to go 1 past that, right? So this would be 2 certain digits, 1 uncertain digit. That would be a situation where we have to go that way. We're going that way.
I thought that you were trying to write the bottom rule
Nope.
there. That's what I was trying to.
Good there?
Yeah.
All right. On your sheets, right underneath the rules, there are 9
Examples.
practice measurements that just so happen to be these 9 measurements.
Wow.
What a coincidence. So, I'm going to pause the recording for a minute and let you guys work on it, because I don't want the recording to pick up the off-topic discussions you're going to have.
Why?
And then we'll come back and reveal the answers.
Bye.
All right, ladies and gentlemen, are we ready for the big reveal?
No.
Yeah.
Ready or not, here it comes.
Alright, wait, I need to turn around.
Sorry, class recording has resumed, so. Alright, so there are the answers to the number of significant digits that each measurement has. Take a look, then we'll answer questions specifically.
I'm really bad at this.
I got this one right. We didn't try it first. I got this one right.
What?
Oh, wow, you're off.
Oh, I got that one right. That one and that one. Not that one. Not that one. Not and that one.
Let's talk about them collectively.
I got the slide down guy.
I'm really bad at these.
Okay, so let's discuss questions. Okay, Jillian.
For the first 2, why aren't they both 5?
Okay, so Rule C states what?
Zeros at the beginning of measurement are never significant.
Okay, zeros at the beginning of the measurement are never significant. The beginning of the measurement is anything before the first non-zero.
Oh.
Even though these 2 zeros come after the decimal point, they are still at the beginning of the measurement. Therefore, the first 3 zeros in the first measurement are not significant. 5 is significant, but then the 0 at the end, according to Rule D, is significant because it's at the end of the measurement and there's decimal. Okay? Other ones. And then, Jillian, does that help on the second one as well?
Yeah.
Okay. Yeah, the second one has 4 because that the 0 between the 3 and the 5 is significant because it's sandwiched, but the other zeros are not because they are at the beginning of the measurement.
Yo comprendo.
Good. What else? Bueno. Any other measurements that we're not quite sure on that we want to discuss?
Just as clarification.
Okay.
But anything that isn't written in scientific notation, the thing that you're multiplying by and with the exponent, like all of those numbers are significant.
So in this part here, right,
Yeah.
the exponent, the 3, doesn't mean anything. It's
Yeah.
just the part at the beginning.
Yeah.
So this one has 2 just because it's 9.5. Right. But this one has 5 because all 5 of them are written.
I feel it.
Yeah.
So with the decimal point, it just makes that 0 significant.
For this one?
Yeah.
Yes. 0, even though the decimal point isn't after the, or sorry, even though the 0 isn't after the decimal point, it is at the end of the measurement.
Okay.
There's decimal point present, it's significant.
But is it, okay, never mind. I'm just gonna confuse myself if I ask that question.
All right, good there?
Yeah.
All right. So let's finish up the notes, and then I'll let you guys try some stuff for homework tonight. So the last part of this outline deals with calculations, because on Thursday and Friday of last week, I had you guys take 2 measurements of the dice. I had you take the mass of the dice and the volume of the dice. And if you kind of put 2 and 2 together, if you measure the mass and the volume, what can you then calculate about the dice? Their density, right? Now, when we measured the mass, we weren't sure about what the mass was, right? We measured it, but that measurement has some uncertainty. When we measured the volume, we measured the volume, but we're not sure about that number. There's uncertainty there. If you then use your uncertain mass and your uncertain volume to calculate the density, how sure can you really be about the density?
Not very.
It depends on how sure you were about the mass and the volume.
Yeah.
So where do we cut it off? That's the next part. So, all right, it depends on what math operation we're doing. First, if we are multiplying or dividing, when measurements are multiplied or divided, the answer has to have the same number of significant digits as the measurement with the least total number of significant digits. So when you multiply or divide measurements, the answer has to have the same number of significant digits as the measurement with the least total number of significant digits. However, when you are adding or subtracting, when measurements are added or subtracted, the answer has to have the same number of decimal places as the measurement with the fewest number of decimal places. So when we're multiplying or dividing, we're looking at total number of significant digits. When we're adding or subtracting, we're concerned with fewest decimal places. And last, sig dig, sig. Depends on what book you use. And last, rounding. Basically, your answers have to be rounded. If you have an answer on your calculator, but you're only supposed to go to 4 significant digits, and the number after the 4th place is 7, you round up. Right? If it's less than 5, you keep it the way it is. Okay. All right, hold on, wait. All right, so those problems out of the book tonight. There are some that are identifying significant digits. There are some that are practicing some simple calculations using these rules. Tomorrow in class, all we are doing is practicing. Okay, I have 2 new sheets for you. We'll practice the significant digits, identify, we'll do calculations, I'll have a bunch of answers for you. That's all we're doing. And then you guys have a quiz on Wednesday over sig digs and measurements. Okay? Have a good night, everybody.
Bye.
Wait, class is